enterprise platforms and AIOps. So what is AIOps? Actually, there's an entire foundation course on AIOps available from One World Training and PeopleServe. So it's something you might want to look into as well as a follow-up to this course, by the way. So AIOps combines machine learning and generative AI to manage complex, fast-changing IT environments. Uses machine learning to detect patterns, spot anomalies, and predict potential failures, while it uses generative AI to interpret vast data sets, create human readable insights, and recommend options for action. It delivers intelligent automation to remediate issues before they impact the business, so in a predictive sense. It leverages reinforcement learning to continuously improve accuracy in event correlation, anomaly detection, and root cause determination. So AIOps is bringing operation security and automation together with integrated insights and automated actions. So if you look at each of those, at the operations end, improving digital experience monitoring, processing observability data, improving network performance by looking at network data, monitoring diagnostics, improvements, IT infrastructure monitoring data for DevSecOps, service ops, chat ops. And the security end, there's a number of acronyms here if you're not familiar with them. So CSOC is the Centralized Security Operations Center, can use AIOps. SIEM, Security Incident and Management Event Systems. SOAR is Security Orchestration and Remediation. UEBA is User and Entity Behavior Analytics, and NLP is Natural Language Processing. So all of those things can help improve security, both prior to deployment and during production. Automation, AIOps can help with root cause determination, anomaly detection, event correlation, close the loop on remediations and insights, as well as dashboarding. So here's Gartner's view of how AIOps platforms can enable continuous insights. So it's a little bit complex diagram. Let me walk through it a little bit. So really, it's all about providing continuous insights across IT operations monitoring, ITOM. Real-time and historical data can be used. In other words, metrics, events, traces, and topologies can be observed to generate historical analysis, anomaly detection, performance analysis, correlation, and contextualization. Meanwhile, incidents and dependencies and changes can help IT service management engage and reduce task automation, change risk analysis, performance analysis, and knowledge management. And automation can help us developing scripts, runbooks, and application release automation. That's what ARA stands for. Basically, it's essential to effectively ingest, prepare, and transform data to make it consumable and ready for AIOps, similar to DataOps. Quality and fidelity of data are key to AIOps success, just as it is for observability. So here's an activity we recommend you spend 15 minutes reflecting on this. Have you implemented any kind of automation, closed loop remediations using observability data in your organization? So you can think about that, or if not, maybe some other use cases. I put together a few example use cases that you can probably do a little research and figure out others. So auto scaling metrics can detect sustained high CPU and latency. That could be supported with high performance scaling pods. Have metrics to confirm SLO recovery if you have SLOs for your services, service level objectives. Can be used for self-healing, health checks, or error rates can spike. Then orchestration could restart or replace the failing instances, and then traces could verify the flow is normalized. Another case would be traffic shaping. So latency or error budgets get breached. That can lead to load balancer shifts in traffic and enabling circuit breakers, and monitoring can confirm the stability. Finally, but not finally, really, this is just another example. So configuration rollbacks during a deployment. So deployment increases in error rate, so you trigger alerts. do an automated rollback, and create logs and traces to validate the recovery. So again, stop your video, spend about 15 minutes looking at the use cases. Okay, assuming you did that, let's talk about domain-centric and domain-agnostic AIOps. So domain-centric solutions apply AIOps for a certain domain like network monitoring, log monitoring, application monitoring, or log collection. We'll deep dive into particular applications. Domain-agnostic solutions can operate more broadly and work across domains, monitoring, logging, cloud, infrastructure, and so on. These tools operate on a vast amount of IT data ingested from all the domains, and they come up with models from this data to provide more accurate inferences and decisions. So obviously that's a higher level of inference. Enterprises without AI attempt the impossible. I mean, you could argue that modern systems is pretty hard to operate effectively without AI. So the AIOps market size is expected to grow from 12.3 billion in 2024 to 123 billion by the end of 2037. So long-term forecast, but in general, they're talking about a cumulative average growth rate annually of 19%. So however way you cut it, it's definitely a growing concern. Deterministic AI helps with root cause identification. We'll walk through an example. The diagram on the right is kind of the example. It's an example from Dynatrace. Dynatrace, as you probably know, is an application performance monitoring tool. It can help you look at performance. So let's say the example is a web app exhibits an anomaly like a reduced response time. First of all, the AI engine takes a first look at the vertical stack below and finds that everything performs as expected, which rules out problems there. Then the AIOps follows the transactions and detects a dependency on service 1 that also shows an anomaly, that does show an anomaly. Further dependencies, services 2 and 3 exhibit anomalies as well. So AIOps tools can correlate metrics and events, identify anomalies, reduce noise, and those actual issues. So the next slide continues the example. So for the automatic root cause detection includes all the relevant vertical stacks shown in the example and ranks the contribution to determine the one with the most negative impact. In this case, the root cause is a CPU saturation in one of the Linux hosts.